Hello, welcome to another video on gPROMS. Today we are going to look at an electrical problem where we look at the simple RL circuits. There are two cases here. The first case is when Ohm's law holds, and the second case is when Ohm's law does not hold. So the circuit dynamics are given for the two cases. So when Ohm's law holds, then the dynamics is described by this equation, by this differential equation. And when Ohm's law does not hold, then it's described by this differential equation. So in the second case, where the real resistors are used that may not obey Ohm's law, then there's a reference current that is used here. So this I is a reference current in the equation. So what we want to do, we want to simulate these two cases and then compare the results for current I as a function of time for the two cases. Okay, so let's see how we can do this in gPROMS. Okay, so here is the model that I've already created. You have the Kirchhoff model, that's the one we need. And the variable type is already created as well. There's the node type that we need there. Okay, so you have the equations. So the parameters are declared are L and I, the voltage. What I've done is for the case where the current is ohmic, so I have I ohm as the first case, and the current for the second case where Ohm's law is not obeyed is declared as I non-ohm. Okay, and this is the first equation, and this is the second equation. Now, here, two variables, two equations, so no problem with degrees of freedom. In the process, there are two cases here that I want us to consider. So I want us to consider a case where we just run the simulation normally. We just run the simulation normally, and I comment this out. To comment out a block of code, you can use that raised bracket at the beginning and at the end. Okay, so that will be commented out. Then I want to use this first part. Okay. Now, I created a copy of that model, then set the parameters, then provide the initial conditions, and then I can run it. So if I run it and send my result to gRMS, I can plot the profiles for the current for the two cases. So let me do that again. Send the result to gRMS. Then expand that to the non-ohmic one and the ohmic. So you can see the difference in the profile. So for the non-ohmic one, so the decay in the current is slower compared to the ohmic one. Okay, and you can see that clearly. Now, if I close this, then now let's look at the second case. The second case where we want to do like a sensitivity analysis on the I, on the reference current, and see how that impacts the decay of I. Okay, so that's what we want to do in the second case. In the second case, and there are two ways to do this. The first method is to, the first method is to create an array. And no, for the two cases, we need to create an array of reactors. So for this first case, I need to create a parameter iteration. So this is how many times do I want to run the sensitivity analysis to repeat that I value. Then create an array of the values I want to use for the current. So I call it I sense. So it's just an array, and I'll put those values in that array, or in like a list of those numbers I want to use. Then create an array of reactors. So an array of an array of the model that I created. So remember I have a model created here in the model. So I've created like several copies of that. Now, in this case, 5 copies of that. So for each of that, I'm going to set the value of I sense. Okay, so this is the list that I want to use. So for the first iteration, there will be, I'm not going to change, I'm not going to add anything. The second case, I'll add 1. The third case, I'll add 2. The fourth case, I'll add 3. The fifth case, I'll add 4. Okay, so what I need to do is that for each iteration, so that's for k equals 1 up to the number of iterations that I have, then go inside that model. So when k is 1, that means I'm doing the first case here, then set the value. So we just grab the value of I sense that corresponds to that k value. So k is 1, then what is the I sense value in the first position? 0. So you're going to do I equals 0 plus 1. Then the initial condition stays the same. All right, I just loop through each of them and keep the value of the initial condition the same. Then if I do this, then I can run that model 5 times, changing the value of I to these values. Okay, so that's the first case. Then that's one way of doing it. So if I run and send my result to gRMS, then we can see the result. Problem. Okay, let me use the gRMS one to be easier to view. To the outline, so we expand the result case file. Problem 1, I non-home. Okay. Problem 2, I non-home. So what I'm trying to do here is to put together all the profiles to see how the current responds to the change in the value of the reference current. So you can see here that the profiles are not overlapping. It means that it actually responds to change in the value of the reference current. For the first case, for problem 1, the reference current is equal to 0. So I didn't use, I set that to 0. So this should correspond to the ohmic case. And when I change the value of reference current to 1, then that gives this red profile. So you can see when you have the ohmic resistor, the profile, the decay is much faster, and it becomes slower and slower as you increase the value of the reference current. Okay. Let's go back to now I'm going to ignore this one now. So I will ignore this. I'm not going to use it. I can leave it there if I want, but I'm not going to use it. So I'll just comment this out. So then the second method is to loop through each of the model and set the value of I somehow by connecting that to K. So I know how I want to change it. I want to change it by 1 every time. So when K is 1, so I want it to be 0. So K minus 1, that's 1 minus 1 is 0. So that means 0 will be added, which corresponds to that. Then when K is 2, 2 minus 1, that's 1. 1 will be added, which corresponds to that. When K is 3, 2 will be added, which corresponds to that. When K is 4, 3 will be added. When K is 5, 4 will be added. So that's a smart way of doing it. Instead of creating this list, we can write like an expression which will help you add the value that you need as you change the number of iterations, the iteration that you are looking at. Okay, so if I do that, I'm going to use the second method now. I'll run it. I should have the same result. So now to the add line to expand that, then problem 1, I non-home. Okay, then expand the second problem. Okay, then the third problem. Okay, the fourth problem and the fifth problem. Okay. Okay, so this is the profile of all the non-ohmic current. So you can see that the profile, the current is impacted by the reference current I. So if you have, the first case where we have 0 value of the reference current, so that will correspond to the ohmic condition, the ohmic case. So, and we have the slowest decay of the current. So when you increase the value of the reference current, then the decay becomes okay. When we have a case of ohmic situation, we have the fastest decay, and as you increase the value of the reference current, then the decay becomes slower and slower, as seen in this profile. Okay, so if I put the ohmic, what I expect is I should overlap on this black profile. Okay, thank you very much. I hope that helps. So if you are new to this channel, don't forget to subscribe and hit the notification button to get notified of my new video. Thank you, and I will see you in the next video. Bye.